This is Gomathi from Department of Computer Science and Engineering. Today we are going to see about graph algorithms. So before going to the algorithm, we should have to know what is meant by graph. A graph is a composite of set of vertices and a set of edges. So here we have the sample 5, 3, 1, 4, 2, 6. So these are called as a set of vertices, and then these vertices connected by the line. This line is called as a edges. So a graph is composite a set of vertices and a set of edges. Then the graph can be denoted by graph G, E, P. Next we are going to see about components of graph. A graph can have two components. One is vertices, another one is edges. So vertices are fundamental units of graph, and edges are drawn or used to connect two nodes of the graph. So here a graph have two types of searches. One is birth first search, another one is depth first search. Here we are going to see about birth first search. So birth first search is an algorithm used for traversing graph or trees. Traversing means visiting each node of the graph. Birth first search is a recursive algorithm to search all the vertices of a graph or tree. BFS in Python can be implemented by using structures like a dictionary and list. So BFS in tree and the graph is almost the same. The only difference is that the graph may contain cycles, so we may traverse to the same node again. So to avoid this cycles, we are using two parts. One is visitor, another one is not visitor. So now we can see the implementation of BFS traversal. So first we have to declare a queue and insert the starting vertex. Next one, initialize the visited array and mark the starting vertex as visited. Next, we have to check whether the queue becomes empty or not. If the queue becomes empty, the process will be stopped. If the queue becomes not empty, we should have to do the three process. One is remove the first vertex of the queue. Next, mark the vertex as visited. Insert all the unvisited neighbors of that vertex into the queue. So this is implementation of BFS travels. So here we have the example. So this is called as a graph. So now we are going to initialize the queue and visited array are empty. So this is your visited array and then this is your queue. So the pointer always point in front of the queue. Next step, we have to push the node 0 into the queue, that is front of the queue, and mark it is as visited so that it's changed as a red color. Next, we should have to remove the node 0 from the front of the queue and it will be marked as a visited. Next, we have to insert another neighboring node of this node. That is, the 0 node have another two unvisited neighbor, that is will be added in the Q1 and 2. So now we deleted the 0, that is visited node. Okay. So now the Q have first position 1. Okay. Now we have to insert 1 and 2 as visited. Next, we have to check whether 1 and 2 have any neighboring node or not. So here they taken 1 as a visited. Next, it's checking whether 1 has a neighboring node or not. The 1 has a neighboring node 3. It will be added in the queue and 1 will be popped from the queue. Next, we have to check 2 has any neighboring node or not. So 2 has a neighboring node 4. So it will be added in the queue and 2 will be popped from the queue. So here 2 will be popped from the queue and it will be marked as a visitor. Now 3 is in front of the queue. Now checking. Now we are checking whether 3 has any neighboring queue or not. So 3 have only neighboring node 4. So now we have popped 3 from the queue and then 4 it's come front. Now we are checking 4 has any neighboring node or not. So 4 doesn't have any neighboring node. It will be popped from the queue. Then queue will be empty. So now we are checking whether the queue will be empty or not. Yes, it is empty. So now we visited all the nodes in the graph. So the process will be stopped. So this is your implementations of BFS algorithm. The next video we can see about implementations in Python by using Colab tools. Okay, thank you.